So after this very clear talk by Johanna Lepeul on the effects of temperature on early life, I will bring you at the other end of life, discussing the short-term association between temperature and mortality. A lot of this, most of this work has been done by Fanny Lehmann while she was working in our group in collaboration with Grégoire Rey and Pierre-Étienne Allary from CPDC, the National Register on the Medical Causes of Death run by Inserm. So we know that temperature has increased on average by about 1 degree since the pre-industrial period. If we distinguish the oceans and the land, the increase is actually higher on the land with about 2 degree increase in Europe. And what we are discussing here in this session is the possible impact of changes in temperature on health. In order to estimate this impact, if possible quantitatively, that is, to provide an estimate of the number or the share of death that might be attributed to climate change currently or in the future, we need to have an assessment of the hazards, of the health effects of temperature, and an accurate characterization of the underlying dose-response functions. We also need to have an understanding of any adaptation phenomena that may be ongoing. And my talk is focused on these issues on the short term. The question of the relation between temperature and mortality on the short term has been studied for a long time, and results indicate a U-shaped relation globally between temperature and all-cause mortality, as in this landmark publication by the group of Antonio Gasparini in London. So this is based on data from the city of London, where you see this sharp increase in mortality after 22 degrees, and increases also with lower temperature depending on the temperature range. So both very high and low temperatures constitute a hazard for health. This is a short-term association, as I mentioned. When seeing this, several questions arise, including that of knowing how this association vary across space, question of heterogeneity in city resilience, which has been studied in particular in that Lancet paper by Antonio Gasparini and colleagues. The question of any variation of this association across time, which is the question of adaptation, and the question of variability of the association between temperature and mortality according to the underlying cause of death. And I will focus on the two latter issues. Another work led by Gasparini and his team has suggested in particular that temperature also influences the risk of mortality by suicide, with a dose-response function that in some places of the world possibly looked like a U-shape, but you don't see here the confidence intervals, which are pretty broad for this data on Philippines. While in other cities, the association looked more like a possibly monotonous association. So there's a need to have a more specific look at this, and for that reason we undertook this study about the short-term association between daily temperature and mortality, detailing how the association vary according to the cause of death, with a particular interest on suicide mortality, attempting to rank the causes of death in terms of sensitivity to heat or cold, and trying to identify any evidence regarding the adaptation of the French society, in our case, to heat or cold across decades. So as I just mentioned, we studied the French population, relying on the National Register on the Medical Causes of Death, which is a very precious resource that allowed to have data for the whole France. We focused on metropolitan France, considered by administrative region, and used all the available data from CPDC, which date back to 1968, up to 2016 at the time when we started the study. The register has information on the underlying causes of death classified according to the current international classification of diseases and allows to estimate and to identify death by suicide, as is shown on this map, as well as death by other medical causes. There are specific issues related to the identification of the causes of death, and in particular by suicide, with some artifacts, such as here an apparently lower rate of death by suicide in Paris area, which is linked to some issues related to the obtention of data from the medical legal institute in Paris that we took into account in our analysis, and that's not likely to bias the short-term association with temperature. We related these data on the cause of each death occurring in France since 1968, which correspond approximately to 13 million deaths, on which we had the day, the location of the death, and the underlying medical cause, with information on temperature on the same day and on the previous days from the EOPS temperature dataset that provides, through a pretty large number of stations covering the whole country, an estimate by interpolation of temperatures across the whole country on a grid of 0.1 degree, which was averaged, weighted with the population density so as to have an average regional estimate of temperature that could be related to the number of deaths by each specific cause in the same area on each day following the assessment of the temperature. The relation between temperature and mortality was assessed using what is now a classical two-stage time series modeling used in the literature, which models the effect of temperature on various days, so allowing for a time lag of up to 21 days when it comes to the effects of cold. We have to take into account several factors. One is that the causes of death may have long-term trends. This is the example of death by suicide. You see they varied to a large extent across the whole period. This is not what we are interested in. This may or may not, but it's unlikely to be due to temperature. We are only interested in short-term effects of temperature, so we get rid of these effects by controlling for this, by first modeling this long-term association using a spline modeling with a high enough number of knots to take into account these variations, and by adjusting for this relation and removing it to estimate the residual effect of temperature on cause-specific mortality. We also remove the effect of factors with a known influence on mortality, which includes the day of the week. For example, the suicide rate is not the same on the weekend and during the week. The existence of holidays, and also shorter-term trends, such as those due to infections, that are also controlled by a spleen modeling. This is the general model, which has been repeated for each cause of death specifically. And in order to compare the causes of death and rank them in terms of the influence of temperature, we reported the effect of a 1 degree Celsius increase in temperature above the temperature that minimizes mortality. The study of the question of adaptation was very simply studied, replicating the approach by Todd and Valeron, cutting the whole study period in 3 parts. So let's move to our results, starting with the short-term association between temperature and all-cause mortality. You see here that we have this well-known U shape with the minimum mortality around 20 degrees approximately, and an increase both for high and low temperatures. When we study this association distinguishing each cause of death, we notice that it is similar when we consider the causes of death related to chronic lower respiratory diseases, to infectious diseases, which also exhibit that U-shape association. We have similar shape of association for cardiovascular and circulatory causes of death. Also for tumors, malignant tumors, for benign neoplasms, the uncertainty is quite broad because the number of death cases is much lower. In the case of death by accident, there's clearly the increase at higher temperature and not very steep association with colder temperature. That association here might be due to people having more activities leading to accidents during nice days with rather warm temperatures. In the case of mortality by suicide, the association corresponded to a monotonic one with no evidence of an increase in the mortality at the low values of temperature. This monotonous association with mortality by suicide was very consistent across all French regions, as shown here, and it was mostly explained by a very short-term association. That figure is depicting the same association, taking into account also the time lag, which was hidden in the previous models and in a way averaged. Here you see that there's this clear, sharp association between temperature and suicide mortality on the same day. But if we look at effect of temperature on mortality the day after or 2 days after, there's not so much of a clear monotonous association. So a very short-term association. There's no obvious explanation of such an association. We can raise hypotheses. One would be a rather biological hypothesis implying hormonal changes, in particular the serotonin pathway. We know that high temperatures are associated with possibly decreased low serotonin levels, and this low serotonin level have been associated with violent behaviors. Serotonin is known to be lower in death by suicides compared by death by other causes. So that's a biological hypothesis that couldn't be studied, obviously, in the macro data that we had at the population scale. A more sociological one would relate to social interactions being more limited in very warm days, possibly increasing the risk of suicidal act. Of course, these two hypotheses are not mutually exclusive. If we now consider the other causes of death again, trying to rank them in terms of sensitivity to heat, you see that looking at the red crosses, that the cause of death most sensitive to temperature were death by endocrine, nutritional, and metabolic diseases, followed by those by genitourinary system disorders, mental and behavioral disorders, diseases of the nervous system, diabetes, suicide is here. Overall, among the 10 first causes of death, you see that many of them were related to the central nervous system and to the endocrine system, which is maybe not surprising because these are sensory systems that are sensitive to what is happening outside and trying to regulate the global homeostasis of our body in the case of the endocrine system. I will now move to the question of adaptation. I think in a way the development of society can be seen as an effort to adapt to the environment. Architecture allows us to be protected to some extent from the weather and developed in order to improve the efficiency of that protection against extremes and extreme weather events, so that we can expect that adaptation is ongoing. This has been very nicely illustrated by the team of Pat Kinney in the case of New York, with this beautiful data spanning across the whole 20th century, showing strong evidence of a very important amount of adaptation in terms of quantified by the decrease in the effect of a given temperature on the mortality risk. Now this is the very specific city of New York with high reliance, for example, on air conditioning system, which are much less frequently used in European countries such as France, so that it's unclear what we have to expect in this country. You see here the short-term association for all-cause mortality stratified into the three 15 to 16-year period of our study, with some evidence of the effect of a given temperature. Here, the evidence, the relative risk of mortality associated with the temperature of 25 degrees, that tends to decrease in the period following 1985 compared to before 1985. That's a pretty high decrease, actually, because the relative risk decreases from increased mortality by 60% to about 30% for this temperature of 25 compared to 20 degrees. At the other end of the dose response curve, there seems to be a similar effect, which is in favor of also some adaptation to cold, which wasn't studied in the previous publication. So at least for the beginning, for the two first periods of the study at the end of the 20th century, we have some evidence of adaptation. There's no evidence from our data, which might be limited by power and sample size, of a further adaptation to heat or cold after the year 2000. But of course, it would be worth having larger population samples to have a more firm evidence on these issues. So overall, we bring here increasing evidence regarding the effect of temperature on cause-specific mortality, in particular on suicide-related mortality. These are only short-term associations that need to be considered in more complex models and heat and health impact models in order to be translated to long-term impact of climate change. Given this monotonous association with the risk of suicide-related mortality, this brings an additional pathway whereby climate change might be related to mental health. There are several other pathways, some of which are summarized in this publication, that explains that increased stress because of environmental stress or financial stress might influence mental health. We have possibly another pathway that is certainly not totally independent, whereby mental health may be influenced by changing temperatures. So we have provided a description of the association between temperature and cause-specific mortality based on a dataset spanning on about 50 years. U-shaped associations were observed and as was already known for all causes, but suicide mortality, for which the association was monotonous. Among the 21 causes of death that we studied, all causes related to the nervous and endocrine system ranked among the 10 causes most strongly associated with warm temperature. And there was some evidence of temporal adaptation, clearly for warm, but also possibly for cold temperatures, with an adaptation that was clear for the first 15-year period of the study, but possibly not for the end of the study period, which raises the question, which is really a question for which we are very far from having a conclusion of knowing if France, at least in that period, has reached a limit to the capacity of adaptation, which in this case is, of course, a societal and not a biological adaptation. I will stop here, thanking all the collaborators implied in that work, and our funders, and more details are provided in our paper that will soon appear in the American Journal of Epidemiology. Thank you very much.